Hey, what's up? Let's do a little bit of math today. In this video, we're going to talk about graphing linear inequalities. And so what we're just doing is we're continuing to build up on our graphing understanding and our graphing knowledge. Now, we're going to start with a core idea here. And our core idea is that a graph is a picture of your solution. Now, when we were graphing solution, there we go. When we're graphing these straight lines, we can take any point on that line and it will satisfy that equation. We need to keep this in mind as we talk about sort of graphing linear inequalities. So now what we're going to be looking at is something like, and let's just keep it real simple, y is greater than x plus 1. We want some sort of values for x and y, so an x comma y, that will make this inequality be true. And so, for example, if I were to take something like 5, 5, would it actually work? And so let's find out. 5 is greater than 5 plus 1. And we put a little question mark here. And no, that wouldn't work out. So that's not a solution. So we're going to get rid of that. But then we start thinking of maybe some other points that would work. Maybe if we went negative, things would start working here. So let's try another one. Oops, let's go with this. This time, let's try negative 5, 5. Is 5 greater than negative 5 plus 1? And it is. And then we can take some more points and probably get something that would work out just as fine. What if we did 4 greater than, so let's say we had 4, 5, negative 4, or sorry, let's go with 5 greater than negative 4 plus 1. Would that work? It does. And so as a result, we're starting to get a bunch of points that work and make this be true. What's going to end up happening here is we're going to eventually cut this plane in half in some way, shape, or form. And one side's going to work and the other side's not going to work. So it might look like this. It might look like that. It could be a little more shallow. It could be going the other way. We have a lot of variety here. And then what's going to end up happening is whatever side works, we're going to shade like this. And we're going to say, hey, any point in this shaded area will make our inequality true. And so that goes back to this core idea, is that a graph is a picture of your solution. So ultimately, our answers are going to look like that. Now, let's talk about how this is going to happen. So we have two methods. Method 1 is the easier one, but it only works if you have something in slope-intercept form. So y is equal to mx plus b. Now, if we have something in y equals mx plus b, we have less than or equal to, what's going to end up happening is we are going to shade below the line. If we have greater than or equal to, you're going to shade above your line. And that's just how it works. So like when it comes to the shading, you'll either shade above or below. Now, as for the other method, this is where things get a little more complicated. This is also a fail-safe, so it will work no matter what. So let's write that down, fail-safe. And it more specifically works for standard form. Standard form. And this is where we test a point. So, test a point. For example, what I would do is if I had something like 3x plus 2y is equal to 6, or actually it's not equal, we want an inequality, greater than 6, I'm going to test a point. And the point I'm going to test is going to be 0, 0. And the thing I want to see is whether or not this is true. So if I put in 0, 0, I'll get 0 plus 0 is greater than 6. This is a false statement. As a result, I'm going to shade the other side, which is the true side. Now, this might not make much sense right now, but I will explain when we get to some examples. But anyways, these are the two methods we're going to use. If we're in slope-intercept form, it's simply just taking a look at the inequality and recognizing it, and you can go above or below. For standard form, you're going to definitely need to test a point to kind of make sure that you're shading the correct side. All right, so let's take a look at some examples. Before we do that though, we need to make one more distinction here. There's a difference between having a less than and greater than versus having a less than or equal to or a greater than or equal to symbol. When we're graphing and we have less than or greater than, our line is going to be dashed. But if we have less than or equal to or greater than or equal to, our line will be a solid line like that when we graph it. So for example, in number 1, I'm going to be using a solid line because this is less than or equal to. So when it comes to graphing, we'll graph it normally. So we'll find our intercept, which is 6. And we have a slope of 2 over 1, 2 over 1, 2 over 1. I'll get a bunch of points in here. And since it is less than or equal to, I'm going to draw a line like that. Nice solid line. Now I can use the fact that it's a less than or equal to, which means I'll be shading below. So again, if less than means below, so I shade all of this right here, continue my line to go in this way, shade like that, and that is my answer for graphing this. Again, I could take any point from within this shaded area, even the parts like here I didn't technically shade, and it will be true for the inequality. So now, let's clean this all up, and let's do the next one. So notice for green here that I have just greater than. Since it's just greater than, I'm going to have a dashed line when I go to graph it. So go about graphing it normally. The intercept is 0, and my slope is negative 1/4. So down 1 over 4, down 1 over 4, up 1 to the left 4, up 1 to the left 4, right there. Perfect. Now, when I mean dash line, you have to take the time and actually go like this, because points on that line aren't going to give you any good evidence. So for example, if we put in 0, 0, we get 0 is greater than 0. Not true. So you can't use the point 0, 0. Now, since I have a greater than, that means I'm going to be shading above. So I just shade above like that right there. Very good. One more example before we get to the hard stuff. So first, actually, let me go to the eraser. Let's clean all this up. All right. So this one, again, I'm using greater than, oops, we're still erasing. Let's not do that. All right. I'm using greater than or equal to. So I'm going to have a solid line. So let's go to 7, my y-axis, and then I got to go up 2 over 5. So up 2 over 5, down 2 over 5, down 2 over 5. Perfect. Draw a solid line, because again, it's a, what symbol was it? Greater than or equal to. And if it's greater than or equal to, that means I'll be shading above it. So I shade above. And there we go. Now again, what we're doing is we're drawing a picture of our solution. These are all the points that would make the inequality here true. And so we're doing our graphing like normal. We just have to then know what side to shade and whether we're going to use a dashed line or a solid line. Now where it gets a little more complicated is if we're given inequalities in standard form. Here we're definitely going to need to test a point. And I'll show you why in a second here. So test a point. All right, so let's go to the red. First, I'm going to use my intercept method to help me find my points. So x, y, let's see here. If I let x be 0, y would have to be 1. I let y be 0, x has to be 2. So let's see here, we had 0, 1, and 2, 0. Very good. Now take a look at the inequality. This is going to mean I have a dashed line. So let me draw a little dashed line kind of going through here. All right, if you need to, you can try to keep the slope going like that. Perfect. Okay, now normally I see this, I might think I shade below. But sometimes if we have negatives here, it can throw things awry. So what we're going to do is test a point. So I'm going to test 0, 0. When I do that, I get 0 is less than 4. Now at this point, this is more of a question mark. All right, like I'm asking, is 0 less than 4? It is. That is true. Now the point 0, 0 is right here. we've established that this side of the line, the left side, the underside, is true. So we're going to shade it, because the other side would be false. So we just shade that side, and there we go. We've got our inequality from graphing. Now, let's do another one. Let's try it in blue this time. Okay, so let's go here, blue. All right, again, I'm going to use my intercept method for graphing this. So 0, 0, or the 0 and 0. I'll let x equals 0. Y would have to be 5. If I let y be 0, x is -2. So -2 on the x-axis, +5 on the y-axis. Take a look at my inequality. I'm going to have a solid line, so I'm going to connect these with a solid line and keep that line going like that. Now I need to test a point. So I'm going to test 0, 0 and see what happens. Here we got to be careful because negatives can throw things around a little bit. So I'll get 0 for x and 0 for y. Combine them, you still get 0. Is greater than or equal to -10. Again, this is sort of a question mark, and that is a true statement. So if 0, 0 is right here, and that's true, we'll shade this side of our graph like that. Now, if we look at the inequality, it was greater than. I may have thought I should go above, but because it's in standard form and I would try to get it into slope-intercept form, I'd have to divide by some negatives. That is why we're ended up shading below. And so that's why for standard form, I like to say, hey, let's test a point to see if it actually works. All right, finally, let's go with this. And let's see here. I'm going to change something really quickly because I can kind of see where this is going. Let's make you greater. All right, now let's clean up our board so we have something to work with. Cool. All right, so last one, let's take a look at this. Again, going to use the intercept method here to figure out what my points are. So 0 for x, y has to be -2. If I let y be 0, x has to be 3. So let me see here, I have -2 on the y, 3 on the, 3 on the x, good, 3 on the x, right there. Now, take a look at the graph. It's going to be a dashed line, so let's make this a dashed line here. So dash, 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 like that. Cool. Now, let's test 0, 0 and see what happens. So I'm going to let 0, or so if I put in 0 for both of these, and I get 0 minus 0, which is 0, greater than 12. Now, this is why I stress, this is a question, all right? This is a false statement. 0 is not greater than 12. So let's go to our graph. Here, this was the point we tested, and we found out that it is false. It does not work. So the other side has to be the true side. So I'm going to shade this side right here. Now, I get that sounded kind of confusing, but when we're dividing our graph up here, let me just kind of draw it out really quickly, like that. The two sides are either going to be, one has to be true and the other one has to be false. Once we've determined which side or which one of them is, the other one has to be the other choice, either true or false. So when I tested 0, 0 here, I found it was a false thing. So I have to go to the other side of this line that I just drew to find the true side, all those points that work. So that's how we graph linear inequalities. Good luck on your practice, and let me know if you have any questions.